At first glance, so many images stream by us, and we may not notice the patterns which decorate our lives. We might at times be attracted to one pattern or another on a sweater, or a tie, or a rug. But do we understand why? Is there any way to make sense of this seemingly infinite variety of patterns around us? Of course, someone had to design all this variety. They must go beyond simply liking a pattern. Researchers have found that regardless of the motifs, different patterns may not be pleasing to everyone. Through the study of the geometrical principles of symmetry, which show us how patterns are organized, we can see that those which may look different may really be the same, and we can better learn which patterns may be pleasing to different groups of people. Archaeology sites are a rich source of decorated objects for research into geometrical patterns. Dorothy Washburn has researched and written extensively on using the classification of pattern designs as a tool for the study of decorated pottery found in sites around the world.
Describing objects by the repeating patterns or symmetries gives us insight into the way a cultural group uses design to identify itself and to represent the way they conceptualize their world. The geometrical principles that we use for such kinds of studies are really quite simple.
The first geometrical principle underlying all pattern research is that of rigid motion. This term is defined as motion across a plane with no change in shape or size. We are concerned here only with flat figures, such as squares, circles, triangles, and other non-three-dimensional motifs that might appear on the surface of walls, textiles, or other decorated surfaces, including objects such as pottery, which have a surface that can, conceptually at least, be flattened into a plane. Mathematicians have shown that there are only 4 basic rigid motions: translation, reflection, rotation, and glide reflection.
These vessels are from the Anasazi tradition, which flourished in the American Southwest from the 10th through the 13th centuries. To keep things simple today, we're going to focus on the one-dimensional or strip designs, which are bands which encircle the vessel on the interior or around the exterior, as opposed to the two-dimensional or wallpaper patterns or a finite design. The first rigid motion, translation, is perhaps the simplest. Moving any image across the plane without turning it is called a translation. The direction it moves, and by how much, is called its vector. On this pottery example, the strip pattern has a motif which translates in one direction across the vessel. The second type of symmetry is called reflection. You can see how each motif contains a mirror image of itself. This is a common symmetry you may already be familiar with. The human body has reflection symmetry. Note, however, that with this figure, the mirror line only runs vertically, so it will only allow vertical reflection symmetry. On this vessel, you can see the vertical reflection, and here is the mirror line. However, with this vessel, there is horizontal reflection. You can see that the mirror line runs horizontally. The third type of rigid motion, rotation, has exactly one fixed point, which is at the center of the rotation. Each motif can only rotate a half turn, or 180 degrees. This is sometimes called a bifold rotation. The fourth and final type of rigid motion is called glide reflection. Note the translation, or glide, is followed by a reflection along a line parallel to the direction of the translation. A simple example of glide reflection is the pattern formed by alternating left-right footsteps when walking. Note the translation on each side of the mirror line. Or, if we temporarily remove the mirror line, you can also see a translation of each pair of left-right footsteps. On either side of the mirror line, you can see the reflection, which follows each translation. On this pottery example, you can see the glide reflection. Here's the translation, and here's the reflection. Here's the translation, and here's the reflection. Here's the translation, and here's the reflection.
These basic rigid motions, translation, reflection, rotation, and glide reflection, are the foundation for all pattern classification. Again, our examples have primarily been what are called one-dimensional or strip patterns. No matter how complicated a strip pattern may appear, it will always be classified as one of 7 classes. All strip patterns have translation, though in one direction only. We have seen that strip patterns may have reflection, which can be vertical, or horizontal. In addition, a pattern may have both vertical and horizontal reflection. We've seen that some patterns may have rotation, which again, with strip patterns, can only be half-turn or bifold rotations. Otherwise, they wouldn't translate in a single direction. We've also seen that patterns may contain glide reflections, though some glide reflection patterns may also have vertical reflection. The triumph of geometry is that no matter how complex or varied strip patterns may seem to us, they are always one of these 7 classes.
Let's look at a series of Anasazi vessels which have examples of all of the 7 strip patterns. Here's an example we've seen previously of translation, and here's the example of vertical reflection, horizontal reflection, and here's a new example which combines both horizontal reflection and vertical reflection. Here's the example we've seen previously of bifold rotation and glide reflection. And our final example shows the combination of vertical reflection and glide reflection. It's important to remember that any strip pattern we might find must be one of these 7 pattern classes.
In addition to strip patterns, motifs may also be combined in the 2-dimensional or wallpaper-type patterns, which allow translation in 2 directions across the plane. Mathematicians have shown that these patterns always fall within one of exactly 17 possible classes. These principles of symmetry and rigid motion can be applied to many different fields. For example, textiles, both new and old, can be designed and studied according to the same pattern classes which we have seen applied to pottery. Carol Beer is a curator at the Textile Museum in Washington, D.C.
At first glance, Oriental carpets appear to have very complicated and intricate designs. But when we look carefully at the patterns, we begin to see that they too are based on rigid motions. The overall effect is one of translation. But when we look at the diamond motif, we see that it's based on horizontal reflection and a vertical reflection. In the border, there's more going on, but we still see the basis of reflection. Here we see another example of a carpet with the main border based on reflection, both a horizontal axis of reflection and a series of vertical axes of reflection. In the border beneath, an S-shaped form is repeated to form bifold rotation. Beyond the basics of pattern, the appearance of complexity is achieved by variations in color. Here we see an overall repeat pattern in the central field based on glide reflection, like footsteps. Patterns in handmade Oriental carpets are often filled with surprises. Designs are introduced which break the symmetry, and it's often the playfulness with symmetry that makes handmade carpets so interesting.
The 4 rigid motions presented here are the foundation of pattern analysis. In addition, a great deal of research goes beyond the details of just classifying patterns.
Now that we have seen how the 4 rigid motions can be used to produce a number of different kinds of repeated patterns, it's really important to ask the question whether this kind of classification system can be used to study real-world problems. I have found that 75% of the Anasazi patterns are structured by bifold rotation, which is typified by interlocking motifs. These interlocking motifs symbolize 2 of the important components of life, water and the union of men and women. So we see that the application of a few simple principles of geometry has led us to some important insights about repeated patterns. In this case, that the symmetries themselves embody cultural belief systems.
In fields as diverse as the manufacture of wallpaper, to the reconstruction and understanding of past and present cultures, the geometrical principles of symmetry can provide insights about how patterns are constructed and why certain patterns are preferred by different peoples. We can only wonder about what marvelous things the study of symmetry will reveal in the future about the world around us.